Good morning, students. Welcome to new session on real numbers. Today we will discuss about the topic real numbers. Actually, in earlier classes we have learnt about some kinds of number systems, right? Now let us go with one flow chart. So here I will write one flow chart like this. So with that we will go real numbers. Real number consists of rational numbers, set of rational numbers, and set of irrational numbers. Real numbers consist of both set of rational numbers and set of irrational numbers. And you know the set of rational numbers denoted by capital Q, and here we can write capital R. About irrational numbers, that one you know, SRQ dash. SRQ dash. These two numbers are very important here. In the previous class, in the 9th class, we have both the rational set of rational numbers and as well as a set of irrational numbers. And we have find the value of irrational number also. Right? Those features also we will discuss now. Again, this set of rational numbers divided into integers. The set is denoted by capital Z or I. I also we can use, it is of no problem. And here we may get fractions, set of fractions. In the set of fractions, we get both the positive fractional numbers and as well as the negative fractional numbers. Right? Here we will discuss only positive fractional numbers. And here it is a set of integers. Set of integers denoted by Z. Actually, all these we have learnt in earlier classes, previous classes. Firstly, we will recall these concepts, then we will go for the exercises. Right? And here integers. Again integers. The set of integers divided into whole numbers denoted by W, set of whole number denoted by W, and here negative integers. Again, set of whole numbers divided into two parts. One is natural numbers. This set is denoted by capital N, and here only 0. Set of 0. Only one number. So if you know this flow chart, easily we can understand these type of number systems. Up to real numbers already we got in the 9th class itself, isn't it? Just we will recall them, each and everything. Coming to very first one, the natural numbers. And you know, if someone asks you to count something, then everyone will start from 1 onwards, isn't it? So this set comes here onwards. 1 onwards we can. 1, 2, 3, 4, 5 and so on. Here two things you need to remember. See, this set starts from 1. In the word natural, the first letter is N. That's why this set is denoted by capital N. And here the least natural number is 1, and about greater. The greatest natural number can't be defined. That does not exist, isn't it? So that's why I keep the symbol and so on. And so on mean the set has no limit, no boundary also we can say. Here the set starts from 1 onwards. So these are also called counting numbers. Right? So this set is denoted by capital N. N for natural. And you know about the 0. So later on we will discuss about 0. While discussing about integers, we will discuss it. So coming to the whole numbers. Set of whole numbers starts from 0 onwards, 0, 1, 2, 3, 4 and so on. Here the set starts from 0 onwards. Here we can say the least whole number is 0 and about the greatest whole number can't be defined or does not exist, we can say. Since the numbers are infinite, the set of numbers are infinite here. Here in the word whole, the first letter is W, no? That's why the set is denoted by W. Understand? Coming to this, whole numbers and then negative integers, we have one more set, right? So before that, firstly, we will discuss about integers, the set of integers. Set of integers usually denoted by capital Z or capital I for integers. What about Z? Why we are taking the letter Z to denote set of integers? So this is the reason we need now. Actually, you do not have the reason in the textbook. But there is Arabic word that is Jalan. Jahlen. Jalan. Which mean to count. So this is of Arabic word. Jahlen. Jalan. Which means to count. Count something, whatever it may be. Right? Here in general, the set of integers will be like this. Very firstly, I am going to write and so on symbol. And here I can write -3, -2, -1, 0, 1, 2, 3 and so on. Here, three kinds of sets we have, three kinds of groups we have. Right? See, 1, 2, 3, 4 and so on. Already we got these numbers. Those are only called counting numbers. Right? In our mathematics, they are called natural numbers. Natural numbers. And you know that all these numbers are greater than 0. You should know two things here. The numbers which are greater than 0 are called positive numbers. Positive numbers. The numbers which are greater than 0 are called positive numbers. And here, -1, -2, -3 and so on we have here also. And these numbers are less than 0 always. All these numbers are less than 0 only. Whatever the numbers less than 0 are called negative integers. So plus V, if I write that is short form of positive. Remember that. And here, whatever the numbers less than 0 are called negative numbers. Negative. This is the short form. So these are of positive integers and these are of negative integers. One number we have still, isn't it? That is 0. This 0 is neither positive nor negative. This is very important point here. Right? In lower classes only we know that. We have discussed it. 0 is neither positive nor negative. Neither nor. You know the meaning. 0 is not a positive as well not a negative, we can say. So these are of positive integers. These are negative integers. And between them we have one number, one integer we have. That is 0. Which is neither positive nor negative. Like that we have three kinds of sets. So here positive numbers we have, negative numbers and one more number that is 0. So these three groups together called set of integers. Set of integers. Why we are denoting with Z? This is the reason. There is Arabic word Jalan, which mean to count. Here, these negative numbers also we can use for counting. Suppose if you lost something, any amount, 50 rupees is lost for you, in any case, then we will write -50, -50, Here we got loss. That's why you can write minus 50. And in some cases, suppose you see in the temperature in the Himalayas, the temperature may be negative, isn't it? So in that case, what you can write? Minus 5 degrees centigrade. Now that is negative value only. So these are the two daily life examples, isn't it? Here, these negative also we can use for counting. Now these three number systems we have discussed in 6th and 7th classes only, isn't it? And the set of integers. So these are very important here, right? So coming to this fractions, here these negative integers also come under a set of integers only. Mean that the negative integers are also what? Completed now. These are only the negative integers. And you know about the number line also. So we will have a number line, natural number line, and as well as a whole number line. It will start at 0 onwards. And here integer number line also we have. Right? So afterwards we will discuss them. Here fractions we have. So that is very important thing we need to discuss now. Fractions. So in general, the numbers which are in the form of A by B, where A comma B belongs to W. And you know about W. So W nothing but a set of whole numbers. Mean A and B are any two whole numbers and B is not equal to 0. B is not equal to 0. Mean the denominator must not be 0. Here, B is in the denominator, right? That denominator must not be 0. So here we may get one doubt. If suppose this B value is 0, what will happen? Let us discuss about it. Suppose A may be any. It may be 0, no problem. That's why here I told you the condition as B is not equal to 0. Suppose if B is 0, what will happen? What about the answer? What can you say? In that case, see, suppose 5 by 0 or else 17 by 0 if you have. So what does A by B mean actually? So we have to divide this A with B. That is the meaning, isn't it? We have to divide A, the numerator A, with the denominator B. That is the meaning, right? So here we can write like this. With B, you need to divide A. Right? Suppose if I gave 17 by 0, then what does it mean? You have to divide 17 with the 0. And you know that with the 0, is division possible? No. Directly you can say division with 0 is not possible. Division with 0 is not possible. That's why B must not be 0 here. B must not be 0. So if you have a 0 by 17, the fraction we have. In that case, what does it mean actually? You have to divide this 0 with 17. Now this time it is possible. So we can divide this 0 with 17. 17 zeros 0. Now the division is possible here. And the quotient is 0 only. But in the previous case, we can't divide 17 with 0. Or else, you can say like this. Division with 0 is not possible. Or else you can write undefined. Or it does not exist. In some cases, we may write this one as 17 by 0. It is of infinity. So like that also you can. What does it mean actually? It does not exist. Undefined we can say. Can't be defined. So 17 by 0. Like that you can write. So that's why the numbers which are in the form of A by B, where A comma B are whole numbers, any whole numbers, B must not be 0, are called set of fractions. Just these are said to be positive fractional numbers. Why mean? In the set of whole numbers, we never get negative. Isn't it? We never get negative. Suppose if you take A and B from set of integers, then you will get negative integers like this. We may get a negative integer as a numerator or denominator, isn't it? In that case, it is called a negative fractional number. Here, the important thing we need to discuss. So these are of positive fractional numbers. Suppose here A and B are related to set of integers. If those two are taken from a set of integers, then we may get the negative fractional numbers. So we will have positive fractional numbers and as well as negative fractional numbers. Both are together called rational numbers. Rational numbers, right? Now by this, these fractions has completed, right? Now coming to the rational numbers. So these two are very important here. So these are for lower classes, right? Now we are discussing a 10th class topic, right? So this chapter is very easy actually. We are discussing real numbers, no? So that real numbers, set of real numbers consists of both rational numbers and as well as irrational numbers. Now some important features of these rational and irrational numbers to be discussed in this chapter. Understand? So before going to the features, we need to frame the definitions for each. What is a rational number? Or what is an irrational number? So we need to give the definition here, right? So coming to the rational number, the set of rational numbers. Very easy. So like that only we will get the definition. Here, the numbers which are in the form of P by Q, or else you can write A by B, no problem. The numbers which are in the form of P by Q, where A comma B belongs to Z, or P comma Q. P comma Q belongs to Z, Q not equal to 0. The third condition also we need to discuss here. Actually, you do not have the third condition in the textbook. But we need to discuss the third condition also from lower classes onwards. If you discuss that the third condition from lower classes onwards, one here in this chapter, in the fourth exercise we have, 1.4 we have. While doing some problems in 1.4, that third condition will be useful. Got it? So that's why I am telling here. So P comma Q must be co-primes. So what are co-primes? That we need to discuss here. Very easy. So what are co-primes? If two numbers doesn't have any other common factor, if two numbers have only one as common factor, then they are called co-primes. Or else, if two numbers doesn't have any other common factor like one other than one, only one we must have. In that case, that pair called co-primes. So the co-primes need not be prime. That's why I am telling you in the definition itself. If two numbers have only one as common factor, then the numbers are called co-primes. Or else, this condition we can tell like this: GCD of P comma Q must be 1. Whenever the GCD of a pair of numbers is 1, they are only called co-primes. The meaning is same. Or else, in another way, P comma Q must be in the simple form. Simple form. And you know that every fraction, whatever the number in the form of A by B, will have a further simplification. It may have a lowest form, right? So if you have a 14 by 16, see this, 14 by 16. In this case, these three conditions, let us check out these three. Here, P comma Q belongs to Z. Here, 14, 16, both are integers only. The second condition, Q not equal to 0. So here 16 is not equal to 0, right? The second condition also has finished. Got satisfied. Coming to the third, that is important here. And one thing I told you now. While discussing the problems in 1.4, this third condition is very important. That's why. Here, 14, 16. If you take these two, these are not said to be co-prime. Why? Both the numbers will have a common factor 2. But what I told you for co-primes must have one as common factor. Only one. But here if you see, these two numbers have common factor 2. Isn't it? That's why here one thing I told you. Every fraction will have a further simple form. Simple form or lowest form. However it may be. Both are same only. Mean that, so if you divide these two with that common factor, 2 7s, 2 8s. Now it is called a simple form of 14 by 16. Or else it is called equivalent fraction. Equivalent fraction. Isn't it? That's why every fraction will have a simple form. And here this is called rational number. That's why. So this is the third condition. P comma Q must be co-primes. Or else their GCD must be 1. Now what is the GCD of 7 comma 8? The GCD of 7 comma 8 is 1 only. If someone asks you to give example for co-primes, you need not be get confused or you need not be search for many, right? Simply give any two continuous numbers, any two consecutive numbers. Suppose if you take 7 and 8, these are consecutive numbers, mean continuous numbers. If you take any pair of continuous numbers, they will have a GCD 1. If you take 11, 12, the GCD will be 1. And they are called co-primes. 17, 18. Continuous numbers only. And see if you have, these are of not co-prime actually. Suppose if you take 8 by 15, 8 is not a prime, you know that. And 15 also not a prime. Even though they are not prime, here both are said to be co-primes. Why? Already these two are the simple form. The fraction in the simple form we can say. These two numbers will not be divided by any number. So 8 divided by something, 1, 2, 4 like that. And 15 can be divided like 1, 3, 5, 15. But what about both? Is there any number that divides both? No. This time 8 and 15 are said to be co-prime. Even though they are not prime. That's why this point is important here. Co-primes need not be prime. Co-primes need not be prime. So coming to the definition, one time I repeat this. The numbers which can be expressed in the form of P by Q, where P comma Q belongs to Z, Q not equal to 0, and P comma Q are co-prime, are called set of rational numbers. Set of rational numbers. See, one thing you need to know, here natural numbers denoted by n. Set of natural numbers denoted by n. And set of whole numbers denoted by w. The first letter is w, no? That's fine. And I told you to the reason. Set of integers denoted by z. For that I told you one reason. Got it? I also we may use it is of no problem. So coming to the rational number, the word is rational actually, and the first letter is R, but we took Q, capital Q, uppercase letter, that is right. Every time we will use uppercase letter only. We are taking Q to represent, to denote the set of rational numbers. Now what will be the reason? So very simple. So here one thing we have discussed now. So what does A by B mean? It means that we have to divide A with B. And while division takes place, for any problem, if division takes place, then what you will take as an answer? The quotient will be. Undoubtedly we can take what? The quotient only. Right? So here also 8 by 15 we have. And what does it mean actually? you have to divide this 8 with 15. Isn't it? Now this time we will take quotient or remainder. Which one you will take? The quotient. So in the word quotient, what is the first letter we have? Q. This is quotient, not coefficient. Quotient. In that word, the first letter is Q, no? That's why. That's why the set of rational numbers denoted by capital Q, based upon the word quotient, the set of rational numbers denoted by capital Q. So here also we can say, what does the P by Q mean? We have to divide that P with Q. And in this division, we will take the quotient as answer. That's why. So this is the definition. And this third point is very important here. About co-primes also. If two numbers have only one as common factor, then they are called co-primes. So while we have here A by B form, here that third one no need, third condition no need actually. Right? Only two are enough. And in your textbook, for rational number also, these two conditions they have given. But we have to discuss this third one. That will be useful for some problems which we have in the 1.4. Right? So coming to the next one. Still we need to discuss irrational numbers and real numbers. See, up to rational numbers we have completed. Now we have to discuss irrational numbers and real numbers. Right? So these two number systems already we have discussed in 9th class. So even though it was completed, one more time we shall recall these two irrational numbers and real numbers. In our next session, we will discuss about the definitions, definition of irrational number, and what are real numbers, and what are their features. All these we can discuss in the next class. In the next section, we can discuss it, right? Thank you.